Welcome everybody to the Seattle New Verticals Tech Talks. Thank you so much for taking the time from your busy day to join us and to hear us talk about what we're doing here at DoorDash Seattle, specifically in the New Verticals team. Next slide. So my name is Anubhav. For people who have pronunciation questions, Siri calls me Anubhav. Our team, which is the New Verticals team, helps DoorDash customers buy products beyond restaurants from local stores. At the end of the day, we want people to easily find what they're looking for and get it quickly. For me, it's super exciting to work on something that my friends and our families can benefit from every day. Our team, the New Verticals team, is spread across the Seattle and the Bay Area. In fact, coincidentally, tomorrow we are celebrating the first anniversary of our Seattle office. Seattle has other teams as well, like Drive and DashMart, but for today's presentation, we will be talking about the New Verticals team. In the Seattle area, our team has three focus areas. First one is the in-store checkout for Dashers. As you can imagine, in third-party stores, our Dashers have to navigate through their payment systems, make a payment, and walk out of the store. We focus on merchant tools so that we can help merchants be successful in helping us make perfect deliveries. And we focus on collecting ground truth or updating our picture of the world about where things are and how many of those are there in the real world. In today's presentation, we will cover a bunch of topics. Towards the end, we will have a Q&A. We'll try to take questions, whenever we can, but normally we would just wait till the end during the Q&A sessions, and you can post questions in the Q&A box in Zoom, and we will go through them when we get to it. Thank you so much, and we'll start with Victor for his first presentation.
Hi, everybody. Nice to meet everyone here. My name is Victor Leong, and I've been an engineering manager at DoorDash for 4 months now. Having a blast and still exciting every day. I lead the selection and catalog team in convenience and groceries, and my team is primarily responsible for creating data ingestion and processing systems to onboard merchant data, such as catalog and inventory data, into the DoorDash ecosystem. So next slide, please. So just to note here, we are not just a food delivery company, and you might ask why. If we can deliver food, why can't we also deliver other things that you can buy? And that's exactly what we're doing right now. We're expanding into new verticals, and here are some of the categories that you can currently order on DoorDash today, and we'll deliver them to you, such as convenience, groceries, pet supplies, alcohol, home retail, and pharmacy. But for the all intents and purposes of this presentation, I will be focusing on convenience and groceries, which I will be calling CNG in short. So what are some of the technical challenges that we have to face when moving from a food delivery company to CNG? I can think of this in 4 major categories: scale, data complexity, user experience, and operations. For scale, our systems, compared to just supporting restaurants, we have to support merchants that sell a very large amount of items, and they also update their inventory much more frequently than restaurants. For data complexity, CNG data is typically far less accurate, less clean, while also being more complex than restaurant menu items. From a user experience point of view, when you're dealing with very, very large amounts of items, we have to provide new user experiences to enable our customers to efficiently shop and find what they are looking for and make the shopping experience as seamless as possible. And finally, for operations, new processes must be created to support the CNG workflow that did not exist at all in the restaurant workflow. So starting off, scale. So what is the largest restaurant menu in the world? And looking on, and this actually surprised me as well, looking on the Guinness World Records, the largest restaurant menu is a restaurant in Budapest, Hungary with 1,810 items. I have no idea how I can find what to order at this restaurant if I ever go. But in comparison, when we look at some of the numbers, For restaurants on DoorDash, typically it ranges anywhere between 20 to like the low hundreds of items per restaurant. If you think about your favorite restaurant and how many items that the restaurant has, it's probably around this range. Now, for some of our large grocery stores, we can sell up to 100,000 items per store. So if you do the math, that's 1,000 times more items in like the larger grocery stores on DoorDash compared to the larger restaurants, and 55 times more items in the largest restaurant menu in the world. So in terms of store update frequency, restaurants typically define all of their menu items one time, and they change their offerings very infrequently. Like the dishes typically only change when the seasons change and like their food supplier gives them like different ingredients overall. The most frequent types of changes for restaurants is the changes in the availability of a particular item due to supply. But the other like metadata doesn't typically change. But for grocery stores, grocery inventory can change as often as multiple times a day, with much larger changes affecting more items per change. So this is the increase in scale that we have to handle. Next slide, please. So how are we tackling some of these scale challenges? One of the big things that we have to do is we have to opt for more eventual consistency and less on manual operators updating our CNG inventory. So what we do typically is we allow our merchant partners to supply us files in the middle of the night, and we will promise them that we will update their inventory before their store opens in the morning. So eventual consistency can help us create systems of scale to handle extremely large volumes of data. We also need to start automating the onboarding of data and move away from manual work. This is because when you're working with like menus of 60 or like 100 items, it's probably not too bad to go through each item by hand. But when you get to like tens of thousands, like the operator will probably go crazy quite quickly. So we have to invest into onboarding tooling to support large scale processing of data. When you're working with data at a very, very large scale also, it gets much more difficult to detect issues that happen in the onboarding process. So we've also invested a lot in observability and monitoring, adding the logging, adding item recon at each stage of our pipelines to determine what the errors are when we find issues and help root cause and mitigate inventory issues very, very quickly. And any other issue that may come up with the merchant data that is provided to us, as well as data for like some of our downstream services. And to sum things up, we have to operate with a scaling mindset. We're no longer working with small amount of items per store, like in the restaurant space. We have to choose the right technologies and the correct methodologies to scale into the future as we grow our portfolio to additional merchants. So the next topic here is data complexity. And what is data complexity? Data complexity can probably best be summarized in like 6 different buckets. So we have the variability, the consistency of data, cleanliness, timeliness, richness, and accuracy. So very quickly going over each of these. What is data variability? Every merchant passes in their inventory and catalog data in different formats. So as we add new merchants with new formats, you can see this becoming untenable really quickly. Data consistency, items that you know semantically as one thing can have their IDs change over time. And this is just how the grocery space works. UPCs for items evolve over time. And it's difficult to map the same semantic item to like a consistent ID all the time. So we have to find a way to solve this. When we're working with larger scale CNG data, the inventory and catalog data may contain duplicates or invalid records, and that really tests the limits of our ingestion pipeline. For data timeliness, what you can think of is merchant data is not updated in a timely manner. When they send us data like day over day, Like say one day, a merchant tells us they have 100 apples. If they sell out of those 100 apples like midday, then there will be a disconnect between what the merchant thinks is in their store versus what DoorDash thinks is in their store. So we have to be able to solve for timeliness issues. For data richness, retail items require much more fields, and this is to improve customer experience and power our DoorDash workflows end to end. And accuracy, items could be passed in to our systems incorrectly, which lead to poor user experience, and it can even amount to revenue loss if we think one item is something else. So what do we do about these very quickly? In terms of data variability, we can leverage ETL frameworks to transform inputs into a common format. And this helps scale throughout the future as we onboard new merchants with different formats, as long as our ETL framework allows us to configure the mapping easily. For data consistency, we need to find a way to be able to map items, like the same semantic item, to all the IDs over time. And what this allows us to do is to keep the historical items accessible for past order reconciliation. For data that is unclean, the ingestion pipeline that we build should have validation and deduping logic to ensure that invalid records are filtered out properly and they don't appear on the DoorDash page for customers. For data timeliness, when we work with limited data sources, then we don't have enough info to give us the timeliness that we need to. If we want to support intraday and data streaming updates, we need to consult additional data sources to build a more accurate picture of exactly what is in a given store. For data richness, flexible ingestion system that can ingest and process data from a variety of different formats and route them efficiently in a high throughput manner to our downstream data stores. And for last but not least, data accuracy, some of the things that we can do here is to add the observability and monitoring to catch data accuracy issues to ensure that we fix them as soon as possible and bolster our validation logic before we sign off on a particular data ingestion job. So next off, I want to kind of give a brief comparison of what the user experience looks like today. So when you look at the restaurant and grocery user interfaces, for the grocery side, when you have to shop through many items, that's a lot of cognitive load to place on the end user. So we have to group the items and categorize them in a primary category, as you can see, which is produce. And we can have secondary categories that allow users to filter further to find exactly what they want and efficiently shop for what they want. As you can see, the secondary categories in this case is fruit, vegetables, leafy greens, so on and so forth. And the next example is mobile. We provide search as well as like a variety of categories to filter the items on for end users. So the last topic I want to get into is operations. What does a typical store onboarding process look like? Next slide, please. So store onboarding and management. What happens typically is this. DoorDash operators will create a store entity for the merchant. And then afterwards, the merchant sends catalog data to DoorDash operators to curate. You can think about a catalog data as the total items with all the information that is sellable for that merchant's business. And this is all curated and uploaded manually by our operators today. Now, for inventory, this is a much larger scale effort where the merchant will send us inventory files every day for all of their stores. And what this represents is this represents the total sellable inventory for each of the stores at the time of update. And this is something that goes through our system automatically and ends up being served to customers through the DoorDash UI. And of course, merchants can have the ability to activate and deactivate items at any time if item availabilities change. So another process that is, this one's completely new for CNG is if you think about like a restaurant, when you make an order for food, the restaurant will fulfill the order for you. Now, on the flip side, for grocery merchants, they will not fulfill an order or shop for customers. The dasher must fulfill customers' orders and shop on behalf of customers. So there's a whole new workflow that is created to support that. And I'm going to be turning it over to Enrique, Carlos, Jim, and Jasmine to go into detail about the order fulfillment workflow and some of the core problems and challenges that dashers face today. Over to you guys.
Thanks, Victor. Hey, folks, my name is Enrique, and together with Carlos, Jim, and Jasmine, we're going to be diving into the work that we've done to kind of build an in-store shopping experience. Quick intro about myself. I've been working specifically on new verticals here at DoorDash for 1.5 years now, and we're really just getting started. So there's a lot of really exciting work that we've done so far and continuing to build as we look forward to the coming years. Next slide, please. So to understand some of the key challenges about grocery, you really have to think about in-store shopping experiences. And one of the key insights we have is that every shopping experience is different. You might have this experience too when you go to the grocery store and you shop for your everyday essentials. There's a high variability in the items that are available for sale. Some items like meat, seafood need to be weighed, maybe like through a scale at the back of the store or an analog scale right where you pick these items up. Produce needs to be checked for freshness, to making sure that we're getting the right quality of vegetables. Some items need to be scanned, others need to be manually keyed in at the point of sale. So there's a lot of variability in just the general workflow if you're going to send somebody into the store to shop on your behalf. Another key challenge is that every store has a different layout. And this varies by different merchants, as well as within a merchant, they might have different floor plans and really kind of different locations for where they might put items on a shelf. And this can make it particularly challenging to go find those items in an efficient way. Another challenge that we have is that items are regularly out of stock. And what this means really is that merchants don't always know to a high degree of accuracy what's on their shelves. And so a non-trivial percentage of the time, sometimes we will send somebody to go find an item on the shelf and it's not there. And so we need to be able to build robust mechanisms for dashers to have that same flexibility when they go to the store that you might have when you walk into a grocery store and maybe something that you're looking for wasn't on the shelf and you might pick something else instead. And one last big challenge that we have, sorry, go back for 1 second. One last big challenge we have is that different merchants can have pretty different requirements in the store for checking out and kind of reconciling these orders. Some merchants want us to pay at the register. Others would prefer that we use a different checkout line. And so these are all different axes and variabilities that we have to account for. So what we've done is we've actually built a flexible workflow engine as well as an in-app workflow to enable our dashers to be able to go in store and shop at dozens of merchants across the country. We support shopping a wide array of different kinds of items. We actually enable our dashers to be able to locate items based on aisle information that we've gathered. And we've also automated a bunch of the mechanics of having a dasher being able to replace items when they discover that they're out of stock. And we're operating at pretty significant scale right now. And so we're having that like hockey stick growth. And it's great to see that we're able to kind of build a system that's able to tackle that scale. So this is well and good, right? We're able to send folks to the store to shop for convenience and grocery goods. But one of the key problems here is that this platform is really purpose-built for this particular case. And what we've discovered is that we rapidly need to be able to expand the variety of tasks that dashers should be able to do in store. And I'll give you some examples. Merchants are actually asking us to have that capability to actually send our dashers to go and check inventory of items on the shelf proactively. So you can think of like helping our merchants enable their own e-commerce. We want to also have the ability to send dashers in store to maybe take pictures of aisles to gather information about where these particular SKUs or items are located on the shelf. We can take that and turn it into insights to be able to route the Dasher more effectively in the store. These are different capabilities that, in my view, I think we need to move to a general task-based model for our Dashers in the store. And this is something that I'd love to work with all of you to go help build. So with that, I'd like to hand it over to Carlos to talk a little bit about the challenges on money flow and checkout.
Thanks, Amrik. Hello, everyone. My name is Carlos. I'm a software engineer and technical lead for the money flow and checkout team at DoorDash. One of the core parts of the order fulfillment process is checkout, which by itself presents very interesting challenges. At DoorDash, we provide Dashers with a physical credit card powered by Marqeta that they basically use for paying orders at the merchant's point of sale. We compute the order subtotal based on substitutions, refunds, and weight adjustments. And we add a buffer on top that is based on handcraft rules. We create an allowance based on like just-in-time funding of the card. Can you go back to the previous slide, please? Yeah, so we create an allowance to basically fund the card, which means that we're adding an amount to the card in real time, and calculating the best amount is very critical for us. So a small amount can cause card rejections, and a large amount could potentially increase fraud. So another challenge that we face today is basically in the convenience and grocery verticals is the time that Dashers are in line waiting for their turn to pay, similar to a regular customer. So this time can potentially be very large, like many minutes per order, and at scale that translate into like a lot of wasted time that could otherwise be used more effectively. Reducing this time is imperative if we want to continue scaling. And there's one more challenge that I want to mention. It's very exciting about information reconciliation. So today, we basically don't have a closed loop feedback on what the Dasher actually bought at the store. So that means there is a possibility of fraud when Dashers can potentially add items to the final order, which will differ from the original order. And we don't have a reliable way to reconcile data. And it's very important for us to start looking into like adding this visibility into what was actually included on the receipt. Can you go to the next slide, please? Yeah, so we are working on several improvements to our systems, and also like creating solutions from scratch to handle these challenges I was mentioning before. So improving the accuracy of the amount that we put into the cards for Dashers is paramount. So we are tackling this by figuring out more like smarter ways to compute the quantities that we add to the cards based on a number of factors, and just trying to replace eventually the handcrafted rules that we have. On top of that, we also need to consider handling exceptional cases like errors in the when processing payments. We're also figuring out more intelligent and more efficient strategies to reduce the time to check out for Dashers, like integration with scan and go systems and points of sale. So such integrations will require us to think outside the box and create streamlined processes for Dashers to pay quicker, and so deliver faster and move on to the next order. And lastly, we are building a receipt reconciliation system through optical character recognition so that we can convert the physical receipts into digital receipts. This would allow us to actually reconcile the customer's order with the items, the quantities and the prices on the receipt, and which eventually will also allow us to be smarter and have stronger signals to prevent fraud. With that, I will let Jim to continue with the next topic.
Thanks, Carlos. Hi, everyone. My name is Jim, and I've been at DoorDash now for 11 months. So I'm an engineer building products that drive Dasher efficiency. Next slide, please. So Dashers spend most of their time shopping for items in the store. So naturally, we want to optimize for this portion of the job as much as possible. Keep in mind that for grocery orders, Dashers are only presented with a list of items for that particular order. They are tasked with finding these items as quickly and accurately as possible inside of a very large store, normally, a grocery store. So this is a daunting task, especially for Dashers who've never been to that particular store before. And the best way to help them succeed is to pinpoint for them exactly where every item is inside of the store. Luckily, many merchants already have this data handy within their inventory. However, much like the rest of the inventory data, location metadata is very different across all of the merchants. So for this particular feature, we needed to determine an appropriate common schema for this type of data so that it can be displayed for all the merchants on the platform in a systematic way. So calling back to Victor's earlier points about data complexity, we are actually leveraging the work done by his team, which loads this data into our system along with the rest of the inventory feed. And it does so without having to build expensive connectors for every single new merchant to transform that data. Moving on to the next slide. This is how we currently guide Dashers to their items. As you can see, the list of items is broken down into groups which are labeled with aisle and category data. This is just an example for this particular grocery store, but other grocers might have additional data that will surface in the group header as well. For instance, some of them might provide data like shelf numbers to better pinpoint items within each aisle. With the items group in this fashion, it becomes much easier for Dashers to pick all of the items from the same aisle at the same time. Also, the groups can be sorted in some meaningful way so that Dashers can walk through the store in a straightforward path without having to backtrack. So note that, back one last point here. Note that the solution is only an initial version, which is basically low-hanging fruit. But it's already had a pretty major impact across our key metrics. So pick times have dropped meaningfully, and moreover, item find rates have increased. So this will actually greatly improve the accuracy of these orders, and it benefits our customers in a major way. Moving forward, we plan to make some significant improvements that will push Dasher efficiency to the next level. While many merchants do provide us with item location data, there's still a long tail of merchants that don't. We cannot ignore this long tail, as wide selection is something that sets DoorDash apart from its competitors. So the other thing to call out is that some merchants do not provide accurate enough data for us to surface to the Dashers. To solve for this, we'd like to start generating first-party in-store data. And as Amrik has already mentioned, we like to build workflows that have Dashers take videos and pictures of aisles as they walk through the store. And using this data, we will build models that will determine real-world in-store item location. Additionally, we will also experiment with different shopping paths to minimize Dasher walking distance. Individual stores have very different layouts, even for the same merchant. So we may want to employ tactics like reversing items in every other aisle so that Dashers can snake their way through the store. We may also want to reserve frozen or heavy items until the end of the shopping session. And lastly, we want to align incentives by rewarding Dashers for good behavior. In this case, we will offer bonus pay for better efficiency and quality. So if Dashers finish picking items quickly, they will be rewarded for that. Okay, next I'll hand it off to Jasmine.
My name's Jasmine. I've been at DoorDash for over 2 years. I'm currently a backend engineer on the fulfillment quality team, also focusing on the item substitution experience. And today, I'm glad to share with you our strategy to tackle the problem of making good substitutions on our grocery orders some learnings along the way, as well as future plans. To start off, I think we can all agree that the single most important thing for grocery fulfillment is accuracy. Ideally, we'd want to fill the basket with exactly the same items that the consumer has ordered. Unfortunately, this is particularly challenging since items can go out of stock or discontinue without DoorDash knowing, as Amrik pointed out earlier. To better understand the problem space, we interviewed our consumers and Dashers and identified the major pain points in their user experience. As a consumer, a good experience means that all the items that I ordered should be fulfilled with either the original item or a great substitution that's based on my personal preference, which put in another way is really we shouldn't have angry consumers calling support to yell at us for substituting their lactose-free milk with whole milk. Also, on the Dasher side, a good experience means I can make substitutions for items if they go out of stock in stores. I should also be able to find high quality ones that the consumer approves with efficiency. This is particularly important to our Dashers because consumer satisfaction and ratings on the delivery has a direct impact on their future order assignments on the platform. So with these two learnings combined, lead to the two questions we need to address. How do we engage consumers to share their substitution preferences for out-of-stock items with us? And how do we minimize the friction of communication between Dasher and consumer during in-store shopping? With that, our current solution is as follows. First, we would leverage the machine learning algorithms to assign similarity scores on item level. And Kurt, who leads the data science team, will shed light on how his team empowers this in a little bit. Then we would cross-reference any subs ratings history associated with a particular consumer to generate a basic personalized substitution recommendations on a particular order. Then the consumer would have the opportunity to review these substitutions to pre-select any preferences on right after order submission, and which are then provided to the Dasher during shopping if they ever find any items out of stock. Then we collect this feedback from the consumer after delivery is made, feed it back into the learning pipeline, which allows us to further understand the consumer behavior as well as iterate on our machine learning models. And with that, next slide, please. The results so far have been very positive and encouraging. We've seen high engagement from consumers to share their substitution preferences with us. We've seen shorter in-store shopping time for our Dashers and mostly positively rated experiences. And moving forward, we have several plans to further improve this by improving substitution rate, by offering better recommendations, that's on the machine learning team, and build live channels in-app for more effective communication between our consumers and Dashers during shopping. And we can also incentivize Dashers by paying for quality of their shopping. And lastly, we can also do Dasher and consumer profile matching for better shopping experience. Yeah, with that, Kurt from the data science team will be going in depth on the amazing work his team is doing to generate personalized recommendations.
Great, thanks, Jasmine. Hi, everybody. My name's Kurt, and I lead the machine learning team for convenience and grocery here at DoorDash. Going to go deeper into one of the interesting ML problems we're working on that Jasmine just told you about. So to give you some context, I've been at DoorDash about 5 months now. I've been rapidly building up our CNG ML team for a lot of really exciting challenges that we're taking on in the coming year and beyond. So to go a little deeper into this, sort of the way I think about machine learning in this space, really one of the core issues that makes this such an interesting space to be working in ML is the large number of items and merchandise that supermarkets carry. So you may not know this, but over the last few decades, supermarkets in the US have gotten larger and larger to the point where a typical supermarket may carry anywhere on the order of 50,000 different and unique items, or SKUs, if you're familiar with the retail terminology. So if you think about that large space of items that we want to help customers shop, and then if you sort of multiply that by the large number of grocers and convenience stores that we serve, from large chain supermarkets to local independent mom and pop type stores, there's an enormous diversity of content that we offer customers. It makes it a very rich space for ML. On top of that, of course, every customer has unique preferences when they're shopping. That can range from the particular dietary restrictions, whether someone is vegetarian or prefers gluten or lactose-free foods, but also the strength of their preferences around things like brand, price, flavor, and going even a little bit deeper, someone's particular intent at any time they come to us to shop for groceries. So somebody, for example, who has to cook dinner for their family tonight and has several hungry kids to feed, their intent and what they're looking for may be different from somebody who is just sort of stocking up for the week and does not have that same sort of time urgency. So those are all things we need to be aware of and think about in our models. So there's a number of different ML problems that we're solving, and I'll go through a few of them here, again, all sort of related to the large diversity of merchandise that stores carry. So obviously the first and foremost one that may jump out at you is, how do we show customers the items that they want among this huge selection? And there's a lot of rich areas in search and personalized recommendations, other ways that we think about laying out and surfacing items that people may shop for. So here's a screenshot of a typical organization in the app looking at a produce section. So as you can imagine, there's lots and lots of interesting modeling work to surface the right items that are personalized to each customer. But even going beyond that shopping experience in the app, actually fulfilling the order, getting the customers what they want with minimum of surprise or disruption, also opens some interesting machine learning problems. And there's really two steps there. First is predicting what items are in or out of stock at a given store. And then for items that are out of stock, delivering appropriate substitutes when we cannot find that item in the store. So to go a bit deeper into those two problems, we'll go on to the next slide. There are a couple ways we address these pain points. So to start, if we think about inventory and out of stock, we're actually building a very robust, sophisticated model to predict at any given store at any given point in time how likely a certain item is to be out of stock. So to say a little bit about this problem first, we're actually pulling in lots of varied and diverse data sources, ranging from historical data on purchasing patterns and other things we see in the retail industry, all the way up to various types of real-time signal that we get. So as you're aware, we have Dashers going into every store every day shopping for items. So lots of both large-scale historical data and then more precise and targeted real-time data that we incorporate into a model. Now, you may recognize, if you're familiar with predictive modeling problems, we face this classic precision recall trade-off, right? So on the one hand, if an item really is out of stock, we would generally like to deactivate it from the store menu for that day to give them a chance to restock. So we want to prevent the scenario where someone orders something and they don't actually have it in the store. The flip side of that, let's say the precision side, the more items that we deactivate, if they are actually in stock, we're now depriving the customer of selection that they would have otherwise had. So we're working at making this model much better so we can improve that trade-off. But at the same time, given the large number of items in store, we're never going to be 100% accurate on that. So the next problem we think about is, for the cases where an item is not in stock, how do we present the customer with a good substitute? So you can see at the screenshot on the right, we actually in the app collect customers' preferences for what sort of substitutes would be acceptable to them. And we've actually built out this model to recommend substitutes to each customer. So on the next slide, I'll go a little bit into how we actually build out that model. So when we first launched our convenience and grocery service at DoorDash, we faced what's essentially a classic cold start problem, right? So we wanted to be able to recommend substitutes, but we did not have good labeled data because the business was just launching and still growing. So we first approached this as an unsupervised learning problem, right? We thought of this as essentially item similarity. How can we score how similar any two items are? And so to do that, we partnered with some of our catalog teams at DoorDash to, one, build out a taxonomy of convenience and grocery merchandise and label every item in all of our merchants' catalogs. We also looked at other item metadata like brand and flavor. And additionally, we mined signal from item names, descriptions, and images, and basically built a sort of unsupervised similarity scoring model. So that was a great starting point, and it actually worked pretty well as a first pass. But ultimately, we wanted to get better feedback and sort of build a predictive model, a supervised model. And so we worked with the product and engineering teams to launch these customer-facing features where customers could give us feedback on the substitutions we gave them, and also give us selections, tell us ahead of time what they want and don't want. So using that, I'll show you a couple of interesting examples on the next slide of how that improved our ability to recommend substitutions. So when we start with this unsupervised model on the left, if somebody ordered Coca-Cola, we could see that, for example, if somebody was ordering a 12-pack of Coca-Cola, we could identify other Coca-Cola products that were similar in that they were the same brand of soda. So that's one notion of similarity. But as we started looking at customer feedback and turning this into a supervised learning problem about what customers actually want, we started to recognize that when a customer orders a 12-pack of soda, whether that's Coke, what they really want more than anything is another 12-pack, is that quantity of soda, rather than just getting one bottle of soda of the same brand. And there's a lot more nuanced learnings that we got from customer feedback. So let me just show you on the last slide, that's kind of where we've come today. And I want to give you a couple examples of some of the exciting things we're doing right now and going forward. So in terms of our ongoing modeling work, the way I think about it at a large scale is we are actively mapping out the landscape of grocery and convenience store merchandise. And so this diagram here, if you're familiar with T-SNE plots, this is sort of a way, each point there represents a unique item. And this is a way of mapping out a very high dimensional vector space on a two-dimensional image. But it's a very diverse, high dimensional, rich landscape that we're mapping out. We're working on some very interesting and sophisticated deep learning models to do that. A couple of the other interesting data sources that we're working with that are feeding into this. We're doing a lot of NLP work, building out text-based, what we call semantic item embeddings. And you can see there's a great blog post that came out recently from one of the folks on our team, Abhi Ramachandran, describing the deep learning framework that we're using to learn these embeddings. In addition to text-based embeddings, we can do some image processing and learn image embeddings from all of the images in store catalogs. So those are just two of many interesting types of data that feed into these models. And then finally, the next step to take this is not just learning what items are similar, but learning what items are good substitutes in a personalized context, right? And so that is to say, there is this kind of overall landscape we can map out, but every person has their own preferences that you can think of like a filter that may shift that landscape. So some folks may have a much stronger brand affinity than others. Other folks may have hard dietary restrictions, such as being a vegetarian. And so those will change the landscape of what counts as a similar or acceptable substitute from one person to the next. So a lot of interesting and exciting ML work to do here that's having a direct impact in our CNG business, and looking forward to going further into this over the coming year.
We are almost at the end, and I do want to make sure that I remind people that, if you want to get involved, learn more, we have a DoorDash engineering blog, and there's a lot of very interesting posts that our teams post there in terms of the work that we are doing. I would encourage everybody to, bookmark it, go through what we're doing. Our careers page is also linked here, and we'll send out a note to everybody who joined with some more information on how you can get involved. Thank you so much for taking the time out of your busy day to join us today. And hopefully we'll see you again at another Tech Talk.